Okay, hi everybody. Welcome to Module 5, which I've called Motor Behavior and Biomechanics. And there's just a couple of chapters that we tackle in this, but they're big chapters and they entail a lot of things that have to do with exercise science, including some of the ones that people classically think of when they think of exercise science. So, what is motor behavior? And what is biomechanics? Or should we say, what are biomechanics? It's kind of weird grammar, huh? Well, taking them one at a time, let's start with motor behavior. Let's think about motors for a second, and let's think about motors as they make things move. So here's a picture of a robot, and this robot is pretty remarkable. It's made by a company called Boston Dynamics, and you can find all kinds of YouTube videos about what all it can do. It's called Atlas, and it'll kind of creep you out a little bit about what the future holds for our robot empire overlords. But this is a robot that can do a lot of things. It can walk on its own, it can go through doors, it can kind of sense and interact with its environment, it can lift things, it can recover its balance. And it's pretty amazing that it can walk uprightly on two legs. It really hasn't been that long that scientists have been able to have a robot that can autonomously walk on two legs. It's pretty incredible. But this is a robot that moves because of motors that it has. So it has motors that cause things like flexion and extension, and it has motors that help it recover balance and so on and so forth. So you are not a robot, but you do have motors. What are your motors? They're muscles, right? Okay, well, what controls your muscles? Well, that's where nerves come into play. So you have a brain, and your brain is part of something called the central nervous system, or sometimes people just abbreviate it the CNS. And it, along with your spinal cord, allows for neural connections from your brain, your thinking centers, and your motor cortex to the motors of your body, which are your muscles. So here's what you would look like as just a bundle of nerves. The eyeballs are there just for reference. Pretty creepy, huh? Well, those nerves connect, if you want to think of it that way, to muscles. The word we actually use is they innervate the muscles of your body. When you look at how that nervous system and your ability to use your muscles develops over the lifespan, and as you learn how to do different tasks like walking and writing and jumping and running, we call that motor learning and development. And then if you start to look, even after somebody has developed at how they control and coordinate the movements of their bodies for expert movement patterns, that's called motor control. All of that falls under motor behavior. So, what about biomechanics? What do we mean by biomechanics? Okay, well, if you've ever taken a physics class, good for you. Everybody should take a physics class. But if you remember from that class, or even if you've been exposed to this before, you've probably learned about things like projectile motion. That's what you see on the left in this picture. There are two balls there, a red one and a yellow one, and they both fall according to the laws of gravity because they are both what we would call a projectile. On the right is what's called an inclined plane problem. So you have a box sitting on a surface that's on an inclined plane, and because of the fact that it's tilted, there's a certain amount of gravity that wants to pull it down the slope, and there's a certain amount of friction resisting that, and so on and so forth. And you study these problems in a physics class. Well, the essence of biomechanics is that human beings and other living organisms, just like everything else we're surrounded by, must obey the laws of physics. There's just no getting out of it. And so human beings could also be projectiles, and human beings could also be like that box on an inclined plane. See? On the left is one human being jumping into the ocean, and just in case you thought it was like 8 or 9 of them perfectly timed, it's just one, but a multiple exposure photo. And from this angle, you can really see the projectile motion. It's very similar to the motion of the yellow ball in this photo. And on the right, you have a human being on an inclined plane. In Iowa, I used to have to explain that this is a sport called skiing. Here in Utah, it's a lot easier to comprehend. But when you stand on skis on a slope, there's a certain amount of gravity that tries to pull you down that slope. And if you allow that to happen, you pick up speed pretty rapidly. But in the end, it's just an inclined plane problem, a lot like the box sliding on this inclined plane in the previous picture. So, biomechanics is just a way of taking the laws of physics, the laws of motion, that's what mechanics means, and applying them to living systems. That's what the bio means, and that is biomechanics. So, in this module, you're going to explore two things. You're going to explore motor behavior, and you're going to learn a little bit about motor learning and development as well as motor control. And you're going to be introduced to biomechanics as a discipline. And I'm really hopeful that these things will get you excited to study further in this major because they're kind of the funnest, but also they're very difficult classes, but they give you a lot of knowledge about how human beings move around and how they control those movements, which is right at the heart of exercise science. So I'll let you get at the module and I'll see you on the other side for discussion.